Hi everyone. Let's create this animated figure with Maya Mesh. We'll use a Mixamo animation and focus on preparing the mesh, fixing geometry and markers for clean distribution, while keeping the animation intact. Ready? Let's go. I'll be using a mesh that isn't perfectly clean. It has some issues like uneven polygon distribution. This will allow me to demonstrate how to address that unevenness for mesh and how to manage the history stack correctly to keep the animation. Now, let's switch over to Maya. Here, I have imported the downloaded FBX file. This particular mesh includes motion capture markers, which appear as small spheres on the surface. We'll need to clean these up. I'll demonstrate how to remove these unwanted elements while preserving the character's animation. As you can see, when I scrub the timeline, the character performs the idle animation we downloaded. Okay, let's begin the cleanup process. Our goal is to isolate the main body mesh and remove everything else associated with the markers. In the outliner, you can see the hierarchy. We only want to keep the mocap guy_body mesh. To see things more clearly, let's hide the skeleton. Select the root joint and press H to hide it. Now, select all the other mesh parts in the outliner that are not the main body. Press the delete key to remove them. Now, only the mocap guy_body should remain visible, along with its animation. Select this body mesh. Open the Hypershade editor. Inside the Hypershade, look at the materials listed. You'll likely see the main body material and another material associated with the markers in this example. We need to select the objects using the marker material. Right-click on the marker material node and choose Select Objects with Material from the context menu. This should select the marker geometry itself in the viewport. Press the delete key to remove this leftover geometry. We can now close the Hypershade window. Select the mocap guy_body mesh again. If you look at its history in the channel box/layer editor under inputs, you might see nodes like delete component. These are remnants from our previous deletion steps. To ensure a clean history for mesh to work with, but without deleting the essential animation data stored in the skin cluster, we need to delete only the non-deformer history. Now, check the inputs for the mesh again. Only the skin cluster node should remain. If you scrub the timeline, the animation is still intact. Now let's prepare for mesh. Create a simple polygon cube. This cube will be the object that mesh distributes across our character. With the cube selected, go to the mesh shelf. Click the Create Mesh Network icon or menu item. This creates a mesh network. Select the Mesh 1 node in the outliner and open the Attribute Editor, Ctrl+A. Navigate to the Mesh 1_Distribute tab. By default, the distribution type is set to linear, creating 10 copies of the cube in a line. This isn't what we need. Change the distribution type from linear to mesh. New options will appear below. We need to tell mesh which mesh to distribute the cubes onto. Find the input mesh attribute. It's currently empty. Select the mocap guy_body mesh in the outliner. Then hold the middle mouse button and drag mocap guy_body onto the input mesh slot in the attribute editor. Release the mouse button. The connection is made. You can unpin the Attribute Editor tab if you pinned it. Now, let's hide the original mocap guy_body mesh so we only see the mesh result. Select mocap guy_body in the outliner and press H. You should now see cubes distributed over the invisible shape of the character. Go back to the Mesh 1_Distribute node attributes and increase the number of points significantly, for example, to 3000, and press Enter. Observe the distribution. You'll likely notice that areas with higher polygon density on the original mesh, like the face, receive a denser concentration of cubes. The distribution method defaults to scatter. Let's try changing the method to random vertex. While different, this still tends to cluster points based on vertex density. For a more even distribution across the entire surface area, regardless of the original topology, we need to modify the source mesh. Unhide the mocap guy_body mesh selected in the outliner. To focus on it, use Isolate Select. Click the Isolate Select button in the panel toolbar, or press Shift+I. We will now remesh this geometry to create a more uniform topology. Go to the main menu, Mesh Remesh. Adjust the attributes like max edge length and collapse threshold to regenerate the mesh with more evenly sized triangles across the entire surface, including detailed areas like the face. Play with these values until the topology looks fairly uniform. Now that the mesh has an even topology, hide it again, select it, press H. Exit Isolate Select Mode, Shift+I, or click the button again to view the mesh network. You should see the cubes are now distributed much more evenly over the character's form. However, scrub the timeline. You might notice the cubes jitter or flicker. This is because the mesh network is constantly evaluating the distribution based on the remeshed version of the body, and the remesh operation itself is being recalculated on every frame as the underlying animated mesh deforms. To fix this, we need to bake the result of the remesh operation into the geometry before mesh reads it. Select the mocapguy_body mesh, which currently has the polyremesh1 node in its history. Go to Edit Delete by Type Non-Deformer History. This removes the active polyremesh1 node, but keeps the resulting uniform geometry, while still preserving the essential skin cluster for animation. Now, the mesh network is reading a mesh with consistent topology throughout the animation. Scrub the timeline again. The mesh points should now follow the animation smoothly, without jittering. The distribution is now stable and follows the animation. From here, you can further refine the mesh network. Alright, and that wraps up our animated mesh figure. Pretty cool result, right? What did you think? Drop your feedback, questions, or even requests for the next tutorial down in the comments section. I really enjoy reading them and seeing what you guys are working on or want to learn. If you dig this kind of stuff and want to keep learning Maya techniques together, make sure you're subscribed. Cheers for watching. Catch you later.